The moon is one of the most significant objects in the night sky, second only in brightness to the sun. So, how big is the moon? The diameter of the moon is only 3,474 kilometers across. Just for comparison, the diameter of the Earth at the equator is 12,756 kilometers. That's only 27% the diameter of the Earth. The moon is also the fifth largest moon in the solar system, after Ganymede, Titan, Callisto, and Io. In terms of volume, the moon only contains 2.195 by 10 to the power of 10 kilometers cubed. That sounds like a lot of cubic kilometers of moon, but again, that's only 2% the volume of Earth. The surface area of the moon is 3.793 by 10 to the 7 kilometers squared. That's about the same size as Russia, Canada, and the United States combined. The circumference of the moon is 10,921 kilometers. Again, that's only a little over a quarter the circumference of the Earth. Hi, and welcome. This is Braino, the explainer. Do you have a lot of questions you'd like to ask? Are you curious about nature, science, and technology? Then you've come to the right channel. Together we will explore the answers you've been seeking, in a fun and informative way. As you probably can guess, our sun is an average star. Stars can be bigger than the sun, and stars can be smaller. Let's take a look at the size of stars. The smallest stars out there are the tiny red dwarfs. These are stars with no more than 50% the mass of the sun, and they can have as little as 7.5% the mass of the sun. This is the minimum mass you need for a star to be able to support nuclear fusion in its core. Lower this mass and you get the failed star brown dwarfs. One fairly well-known example of a red dwarf star is Proxima Centauri, the closest star to Earth. This star has about 12% the mass of the sun, and about 14% the size of the sun, about 200,000 kilometers across, which is only a little larger than Jupiter. Our own sun is an example of an average star. It has a diameter of 1.4 million kilometers today. But when our sun nears the end of its life, it will bloat up as a red giant, and grow to 300 times its original size. This will consume the orbits of the inner planets, Mercury, Venus, and yes, even Earth. When talking about the size of stars, it's important to first take a look at our own sun for a sense of scale. It is so huge that it's hard to get a sense of scale. Speaking of which, the sun also accounts for 99.9% of all the matter in our solar system. In fact, you could fit 1 million planet Earths inside the sun. Using these values, astronomers have created the terms solar radius and solar mass, which they use to compare stars of greater or smaller size and mass to our own. A solar radius is 690,000 kilometers and one solar mass is 2 by 10 to the power of 30 kilograms. That's 2 nonillion kilograms. Another thing worth considering is the fact that our sun is pretty small, as stars go. As a G-type main sequence star, specifically, a G2V star, commonly known as a yellow dwarf, it's on the smaller end of the size chart. While it is certainly larger than the most common type of star, the M-type, or red dwarfs, it is itself dwarfed by the likes of blue giants and other spectral classes. An example of a larger star than our sun is the blue supergiant Rigel, in the constellation Orion. This is a star with 17 times the mass of the sun, which puts out 66,000 times as much energy. Rigel is estimated to be 62 times as big as the sun. Bigger? No problem. Let's take a look at the red supergiant Betelgeuse, also in the constellation Orion. Betelgeuse has 20 times the mass of the sun, and it's nearing the end of its life. Astronomers think Betelgeuse might explode as a supernova within the next 1,000 years. Betelgeuse has bloated out to more than 1,000 times the size of the sun. This would consume the orbit of Mars and almost reach Jupiter. But the biggest stars in the universe are thought to be the monsters VY Canis Majoris and UI Scuti. These red hyper and supergiant stars are thought to be more than 1,800 times the size of the sun. They would touch the orbit of Saturn if they were placed in our solar system. The Milky Way is our home galaxy, the spot where the Earth resides. We are not anywhere near the center. NASA says we're roughly 165 quadrillion miles from the galaxy's black hole, which demonstrates just how darn big the galaxy is. So how big is it, and how does it measure up with other neighborhood residents? The numbers are pretty astounding. NASA estimates the galaxy at 100,000 light-years across. Since 1 light-year is about 9.5 by 10 to the 12 kilometers, the diameter of the Milky Way galaxy is about 9.5 by 10 to the 17 kilometers in diameter. The thickness of the galaxy ranges, depending on how close you are to the center, but it's tens of thousands of light years across. Our galaxy is part of a collection known as the local group. Because some of these galaxies are prominent in our sky, the names tend to be familiar. The Milky Way is on a collision course with the most massive member of the group, called M31, or the Andromeda Galaxy. The Milky Way is the second largest member, with M33 known as the Triangulum Galax, the third largest. Andromeda appears much brighter in the night sky, due to its size and relatively closer distance. There are about 30 members of this group. Because we are inside the Milky Way's arms, it appears as a band of stars, or a fuzzy white band, across the Earth's sky. Casting a pair of binoculars or a telescope across it shows a mix of lighter areas and darker areas. The darker areas are dust that obscures any light from stars, galaxies, and other bright objects behind it. From the outside, however, astronomers say the Milky Way is a barred spiral galaxy, a galaxy that has a band of stars across its center as well as the spiral shape. Based on observing star clusters in the galaxy, astronomers have estimated the Milky Way's overall age at 13.5 billion years old. Just 200 million years younger than the rest of the universe. Scientists' research indicates that the Milky Way formed in the following sequence: the halo, including globular star clusters and dwarf galaxies, the inner halo, whose stars were born as a result of this construction, and the outer halo, created when the Milky Way ate up nearby ancient dwarf galaxies. Meet Laniakea, our home supercluster. Our cosmic address extends well beyond Earth, past the Milky Way and toward the farthest reaches of the universe. But now astronomers are adding another line, the Laniakea supercluster, which takes its name from the Hawaiian term Lani, meaning heaven, and Akea meaning spacious or immeasurable. And the name is true to its meaning. This supercluster extends more than 500 million light-years and contains the mass of 100 quadrillion suns in 100,000 large galaxies. This research is the first to trace our local supercluster on such a large scale. Looking up at the night sky, it seems as though the stars and galaxies are spread out in a more or less random fashion. This, however, isn't really the case. The universe isn't a random jumble of objects, it has a structure composed of galaxies and gas. Cosmologists call this structure the cosmic web. The cosmic web is composed of interconnecting filaments of clustered galaxies and gases, stretched out across the universe and separated by giant voids. The largest of these filaments that we have found to date is the Hercules Corona Borealis Great Wall, which is a staggering 10 billion light-years long and contains several billion galaxies. The cosmic microwave background, or CMB, is radiation that fills the universe and can be detected in every direction. Microwaves are invisible to the naked eye, so they cannot be seen without instruments. Created shortly after the universe came into being in the Big Bang, the CMB represents the earliest radiation that can be detected. If we define universe as all there is, or all that exists, then obviously, by definition, there can be only one universe. But if we define universe as all we can ever see, no matter how large our telescopes, then many universes may indeed exist. There is nothing in science more awesome, more majestic. If you've learned something new in this video, please give us a thumbs up. And be sure to subscribe and turn on the notification bell. Thanks for watching until next time.